Welcome to this tutorial about GraspR, an application that allows a modular, interactive, visual exploration of databases and analysis of databases. And this project is meant to be a way to manipulate a statistical program called R, which is one of the most used by statisticians in specialized studies and one of the most flexible and precise languages to analyze data. So this application is meant to be used in a table, in a multi-touch table that can recognize objects, but it can also be used as a desktop application. And this tutorial is going to be about this second way of using it, and we will explore some of the main characteristics. To make this exploration more didactic, we will try to answer one question from the data we have, and we will see how we can do it with this program. So, for example, here we have a database by default, which is a weather database. That it's a climate database which contains data from 2000 to 2014 about a few cities in the world of precipitation, humidity, temperature, dew point, pressure, wind speed, and direction. And so it's a huge amount of data, and we can try to ask some questions and get the answers using this visual and interactive program. So let's first try the first question, and this question can be, for example, which is the mean temperature for each city in the data by year. We want to see that in a single graph, and we want to be able to spot some characteristics of those data as in a visual way, and we want to be able to explore that and after to refine some of the data we find. Okay, so let's begin to use the application. So here when we come to this place and we open these three, we can see that we have four kinds of main elements: databases, filters, operators, and visualizations. Databases are the main input of the program. In this case, for this demo, we have a database which is called weather data. So let's grab one of those ones and put it in the board. So once we do that, we see that we have what we call one R element, and in this case, this is a database that contains a huge amount of data, as we said previously, and has some icons that we can touch and manipulate. We can make it be in different places in the board. We could also make it disappear in this way and choose another one, the same, another copy of it. And we will see how with this data we can find many answers to many questions that we have. So if we touch this icon here, which means display on table, this first icon here means display on table, is like make a visualization on the table here in the application of myself. So if we do that for the database, we see a generic structure of it with at the left side we see the columns, and the right side we see the values, unique values that are in the columns, and we only see 5 of them. There is much more of them there. And so we see that we have continent, country, city, year, month, day, date, and numerical variables are temperature, dew point, humidity, pressure, wind speed, wind direction, visibility, and cloud cover. So we can ask any question about those data. So in this case, we want to see temperature by city and year. That's what we wanted to see. So another way to see, a very interesting way to see with this application, the visualizations for each element, it's going to this icon, which means display on the web and page. And if we touch that icon and we go to the web page that it's assigned to this application, we will see that there is an automatic update of the web page that shows the structure or the visualizations corresponding to that data. So here we have, for example, weather data 2, which is the name of the element that we choose to see in the web page. And this is the kind of visualization we have. It's a data table. The size is, we have 69 and 600,000 of rows, and we are showing only the first 150 rows. And this is a visualization in a web page that we can manipulate in real time. So I mean, we can explore it also in this. Not only the program not only allows exploration in the application, but also exploration with the display in the web page that we choose. So we can, for example, scroll the data until the end, and we can also sort the data by any of the columns. For example, we can sort by temperature, and we will see now that we have the first value, the first row of the data now, that the shown ones, it's the minimum temperature. So we can see it's -7, and it corresponds to Denmark in the year 2000 and the day 24. So just the day, the Christmas day was the minimum temperature we got. Okay, so that's the two ways to see visualization of the data. So in this case, it's a simple one. It's a database, and it's going to be the input for every other element if we want to see something about those data. So now we have a filters. Filters mean that to choose some part of the data. So it's a filter. We have two main filters. One, it's a categorical filter, so the filter, and this is a numerical filter. So let's choose a filter to allow to pass only the data for year, city, and temperature. So we only are interested in these three variables. To do that, we must make a chain, so we must assign the filter to the database. To do that, we can touch in this icon, which is the inlet, and go until the outlet of the other element. And then in this way, we create a link. If we want to delete the link, we can go to the void and then delete the link. In this way, let's do it. When we do that, now we see that the icons for the filter now are more. There is more icons. There is 5 of them, and we're gonna try to explain how they are. The first one is the options one. So this means that from the data that we got in the inlet, in this case the database, we have to choose some parts of them to run our filter. So what do we want from this data? So we have city, we said we wanted all the cities, we want the temperature, and we want the years. Let's take all of them. Once we do that, we have chosen that, and if we filter, this icon means run. So if we run the data, it will mean that we have filtered the database, and we got only, as a result, we have another database which contains only city, year, and temperature. So let's check. This is a status check of the element. So it means what do I have inside? So I have city, I selected all, temperature all, and year all. Now, because this this filter is making also a database, I can check how it is, which is the structure of it with this one, and I see that we have three things: city, temperature, and year, and this is a sample of the first 5 unique values of it. Let's see it also in the web page. So if we do that, we will see that we created in an automatic way, we created a new element which is called rFilter2DataTable in the web page, and we can see the first 150 rows that contain only city, year, and temperature. So here we have another thing which can be important, is the path. Path means which is the links between the elements that went until that element that we are seeing. So in this case we see it's wither data too, and we can see that the path is exactly that one. So rFilter2 is the result of making a run of the filter for this data, wither data too. We can make a very complex paths, and we will see some of them. So now we have that. So we have temperature, as we can check here, city we have all of them, temperature we have all of them, and year we have all of them. And so now we need, so for each city and for each year we have many values, because this data contains values for each day of the year. So now we need to make a mean. So let's take an operator which is making some operations, numerical operation over the data. Let's take one of them, the mean, assign the inlet to the data there, and choose which one we want. So in this case we want, these have two options, which are the split columns and the variable columns. So variable columns will be the numerical values we want to make the mean operation, and the split columns is the categorical variables that we want to have as to show the values assigned to them. So in this case it's correct, we want by default, the default that the program made was already correct. So we want city and year, and as the variable we want temperature. So this is okay, we run the process, we check here the status, so split columns year and city, var columns temperature. We can see the display on the table. So we have city, these ones, and there is more of them, and the years, and the temperature for each one of them, the mean. Okay, so now let's check it also in the web page. So we have created another one, and you see, we can see now that the path is wither data 2 to rFilter2 and to rmean. And this is like, so let's, for example, sort for the minimum one, 7.65 in Copenhagen in the year 2010. So we have already one result, for example, that we know that the minimum mean temperature for any city that is in the database for any year in the database, it was Copenhagen 7.65 degrees. It could be the other way. The maximum one was also 2010 for Dubai, 29.64 degrees. Okay, so now we already have some data that we could plot. So let's go to visualization and try to, for example, use, in this case we could use a heat map. Heat map are graphs that plot one value for two categorical variables. So in this case it's a perfect one, because and this plot is by colors, so we can spot in a qualitative way to see the data in one single visualization. So let's take the heat map in this case, and we're going to assign the inlet to the outlet of the mean. And now we check the options, and then we see that the x axis, we want it to be the city, and the y-axis we're gonna make it the year. The value is the temperature, and then we run the process. Some of them can take a while because sometimes the operations they may have to do are quite complex. And we have now two possibilities, is to see it in the table or to display it in the web. In this case, heat map is a special one visualization that makes both visualizations in the table and in the web page. And they are different. They show the same data, but they are made in a different way. The one in the table is made by R command, which is ggplot, and the web one is made as a D3 interactive object. So let's see it in the table. It has generated an image that we can see in the table, and we can manipulate it if we had a table that was multi-touch, and we already see some patterns that we are going to explore better in the web page. So now let's see this visualization in the web page and check it there now. So here we have. So now we see the path with the data to goes to the filter, goes to the mean, and makes a heat map. So this is something that in the programming, somebody who would try to program that would have a huge amount of difficulties to make this visualization. And here it is made in a very simple way, as we said, as we saw, and almost anybody who knows what they want to do could do that. So let's see this visualization. It's we have the city, we have the year, and then we have by colors, we have the values. So we can see that Moscow is the minimum one. Colors come from the typical rainbow values, which are the blue for the cold ones and red for the warm ones. So minimum values are blue, maximum values are red. So this one is interactive, so we could select only one and check what it is. We could select a few, and then with that make some data. If we want to see all of them, we check all of them, and when we point the mouse over it, we can see the values there. So city was Moscow, year was 2014, and temperature was 6.1. This is going to be almost the mean of them, the minimum of 4.6, and the maximum would be, for example, I think it's going to be here 29.6. Okay, for Paris, for example, we have this year, which was different from the previous one, which was the coldest one. We can see that this year, 2010, was a special one. We can see that here, because of the colors. There is something interesting in this one. Also, 2008 seems to be kind of a special one, but I think 2010 is like a special year. So once we have seen that, we have discovered now that Moscow is the minimum, Dubai is the maximum, of course. We can see also for each city almost the patterns that have there. Like Copenhagen has a difference between the years. Like this one, 2010 is the minimum, 7.7, but we have here values of 9.7 and here of 10.4 and here 8.1. But Mexico City has always 15.9, 17, 16. It's almost always the same for each year. But in Copenhagen there is more variability. And in Dubai it's also something that is quite the same, 29, 29, 27, 28. And so we can see some patterns here, interesting patterns that are explainable by the climate there. And but for example, the discovering that 2010 was a special year can be shown perhaps by the same application in another path. So let's explore by year instead of by city and year. Let's explore by year. So now we have the opportunity to check another thing, make another path. So we go to the data that we wanted to have, which was temperature, city, and year. So we have now city, year, and temperature. But now we only want to see by year for the mean temperature by year for every city, because we saw that 2010 was some special one. So let's see if it's true that is a special one. So we go there, we make a run, and we can see here the results, so a sample of them. And let's make another visualization. This time we cannot use a heat map, and we want to use something else. So let's make a plot xy. This plot xy is a generic plot that can take two variables and plot one against the other. In this case, we want to have the year as x and the temperature, and we are gonna use a bar plot to see it better. We run it, we can see it on the table already, or we could also see it, the same image, we can see it on the web. So we generated this one, and if we explore the data, we can see that the minimum seems to be year 2010, and there is one year which is really special, which is 2014. So 2010 is one of the minimum ones. We have also these two ones here, 2000 and 2001, and 2014 was a very warm year in comparison. Another way to see the same data would be for example, a bubble chart. Bubble chart allow to make some values by seeing the size of the disks. So the size of the disks plotted there are proportional to the values of them. So let's display that on the web, and here we have the values for. So these values now, the differences are much clearer than here, and because the human eye is more adapted to see these differences in disk than in. So we can see, we also can see that 15 degrees was the minimum, 15 here also, but this was that's it's an approximate value. Okay, for this was the year 2001, 2000, and this would be 2010. The warmest one, 2014. Another way to see the same data. Another way to see the same would be to choose hierarchical bars, which can be much more complex than this one, but can be shown with the same data. So here we have data ordered by value from 2014 to 2001, 2010, and here we can see the values and the ordering. It's an interactive one, so that means that if there was more complicated data, we could explore it for each one of those bars, but in this case the data we have are the simple ones. That could be done, for example, if we want to see the data we had before for hierarchical bars, and the data we are seeing here are by city and by year. So here we have the city, and this is the accumulation of temperatures for each year. So this is the sum of the temperatures for each year, and if we go inside, we can see for each year which is the structure of it. So we have a very good interactive plot which says a lot about which it's almost the equivalent of the heat map we had here, but in a more interactive way and a more precise way if we want to see which are the values of them. Another way to see those data it's using a hierarchical tree that so we want values, we want city and year as the, and there is too many to display, so we cannot use that now, and we will explore this element in another tutorial. So we can see this is one of the ways to use the application. There is many possibilities, many paths to save. We can save the configuration for future explorations. We can also see the results in this because all what we have done is there now, and we could save that too, and we can access each one of the results in this auto-generated menu here. So this is all for the first tutorial about this GraspR application, which is a revolutionary way to explore databases.